Hello, welcome back to General Science. In this episode, we're going to finish off our talks about chemical reactions by talking about some specific types of chemical reactions. This specific one being acids and bases. So we're going to talk about acid-base reactions a little bit, just kind of the real quick basics. Um, and then still trying to get it together, but we might do a quick little demo um, in the next video. So we'll get to see an actual chemical reaction. You can observe one on your YouTube. It'll be great. So let's get started. Acids and bases. So first, I want to just talk about what acids and bases are. And so acids and bases have two particular definitions that have kind of developed over time. The first one for an acid is just any substance that can donate a proton. And a proton is really just a hydrogen atom. So hydrogen atoms only have one proton because it's the first element. And so if if something ionizes and gives off an H, that H doesn't have any electrons on it, so it's really just a proton getting added onto something. So that makes something an acid. Then a more broad definition is that it's a substance capable of forming a covalent bond with an electron pair, and that increases the number of things that can be considered an acid to things that don't just have H's, hydrogens in them. And then for bases, bases are substances that dissociate to form hydroxide ions, which is an O and an H together, um, or it's a substance that can accept a hydrogen cation, so it can accept a proton. So basically, they're kind of opposites of the same coin, right? Acids are things that can donate protons, and bases are things that can accept those protons. So that's what makes them special. There are particular chemicals that can do those things. So let's talk a little bit more specifically about acids. Acids can be really corrosive, right? You don't want to have acid on your body or whatever, right? It's not great for you. It can disintegrate your skin, do all sorts of bad stuff to you. It's very reactive with bases. Okay, so acids and bases react together very violently, so you got to make sure you keep those away from each other. How we measure acidity is something called pH. It's basically a measurement of how many hydrogen ions are around. So it's a concentration value. And anything that has the scale goes from 0 to 14, and anything that's below 7 is considered acidic. So if you have a pH of under 7, it's an acid. And then acids are often sour. So the ones that you can ingest, they are often sour tasting. Here are some common acids, just so you kind of have an idea of things that you might want to think about that are acidic. Some things like gastric acid, so inside your stomach, there's acid that helps digest your food and activate the enzymes that helps you digest your food. And then citric acid, which is in fruits, right? Think about a lemon. Lemons are sour because of the citric acid in them, and that's why they taste the way they do, because of that acid in there. Bases, on the other hand, similar to acids in some ways, right? They're not great for you. You don't want to get them on your skin. You don't want to ingest them. Okay, the strong ones at least. They react violently with acids, just like acids react violently with bases. Here's where the differences are. pH is over 7. So anything under 7 is an acid. Anything over 7 is a base. And bases are bitter tasting. So things that taste bitter usually have some sort of base in them. Some common bases that you may have heard of. Most soaps are bases. That's what we use to clean ourselves, and baking soda, which we use in cooking, is a base. So those are some household bases that or things that you might be familiar of that are basic. So let's talk a little bit about how these react. There's two main types of acid-base reactions that you're going to cover in a basic chemistry course. And the first one is always going to be neutralization. Okay, neutralization is what occurs when an acid and a base react together. Okay, so when they react together, they're going to basically cancel each other out. So you're going to start with an acid and a base. They're going to react, and then the two things they always get as the results of that reaction are a salt and water. Okay, so if you think about it, right, hydrogen ions are this H, and hydroxide ions are OH, right? And if you stick H and OH together, that makes H2O. So water is always going to be a resultant of some sort of a reaction that deals with acids and bases. You're always going to get water because you're going to get hydrogen and hydroxide ions combining to make water. Now the leftover things, the other ions that are left over from these reactions, they're going to become a salt. And in this case, we're using the broad term salt, which means anything, any ionic pairing um, of a halogen and a tier 1 or tier 2 metal. So those are going to be your reactants or your products for those reactions. Now, the other type of reaction that acids go into a lot that scientists look into frequently are equilibrium reactions. So basically, all reactions have an equilibrium rate, which is basically just how fast they occur. And so some reactions, they happen quickly and immediately, and they go through and they're done. Okay, but there are other reactions that take so long to keep going that sometimes the reaction will reverse and go the other way too. And so one part of the reaction will be going towards the products, and then sometimes the products will break back down and go the other way. And if those rates are similar enough, you can create what's called an equilibrium. And so that equilibrium basically is this kind of steady flow between the products and the reactants that's making this standard state of where these chemicals are going to be during this reaction process. And so knowing what these equilibriums are and what they can do is really important because inside of our own body, for instance, there are equilibrium reactions that are occurring all the time. So for instance, our blood has a constant equilibrium reaction going on within it because our blood needs to maintain a certain pH level. Otherwise, things don't go very well. So if there's basically our blood is designed to handle what happens if we get a little bit of acid in us and a little bit of base in us. It can handle that. Plus, some of the things we ingest already are acids or bases, so it has to be able to handle those changes as well. So those are the two major types of acid and base reactions. Real basic understanding, real basic overview. Not going to do any balancing of these reactions, not going to do any of that. Just wanted to let you know what they are. So thank you so much for watching this episode of General Science. Our next video, we will be doing a demo of a chemical reaction. It's probably going to be one that you could do it in your own home. So if you want to be able to see it and do it yourself, totally could do it because we're going to be using household items to make this reaction happen. And we'll talk a little bit about it and why it's cool, all the different things that are occurring with it. And then after that, we'll be moving on. We'll be done with our chemistry section of this course, and we'll be moving on to the next section, which, if I remember correctly, my notes are gone. My son's in here working with me today, so the things are moved around, but we're going to be moving on to a different science. It's not going to be biology. It's not going to be chemistry. There's only two other options. I think it's physics, but that's where we'll go. So thank you again so much for watching, and we'll see you next time. Bye.